Hello everyone. So we had a quiz this week, which was week 6. So we had a lot of questions in that quiz, and there are some questions which are quite straightforward, but there are few questions which are little kind of lengthy, or they demand some fundamental understanding of electronics. So I thought that I should make a video to help you guys how we can solve those circuits. So starting with question one. So what I'm going to do is let's take the screenshot and I will put it into the yeah. So okay. So there are different combinations. So the main thing is what we need to do is that this bulb has to be activated. The question is for which of the following combination of inputs the bulb will glow or it will be on. So the bulb will be on if it gets 1 from here or 0 from here. For example, the bulb can be on if it gets 0 from here and 1 from here, right? But it cannot be on if it gets 0 from both sides or even 1 from both sides, right? So we need to see that what pattern of inputs can create either this kind of situation or that kind of situation, right? So starting with, for example, the option 1, so it is A equals to 0, so we are giving 0, B is 1, C is 1, and D is 1, okay? So see, this is NOR gate, okay? This is NOR gate. NOR gate means there are two inputs which will first be added, and then whatever the output is, it should be inverted, right? And then we have AND gate. AND gate is like multiplication of two inputs, and whatever the output is, it should be inverted. So in that case scenario, the A is 0. That means it has got two terminals. 0 will go to this terminal as well as this input. So 0 plus 0 would be 0, and because this is inverted, that means you will get 1 here, right? And if we see 1 multiplied by 1 is 1, but 1 is again inverted, so we will get 0, right? And 1 will give you 0 here, okay? And then 1 plus 1 would be 1, but this is inverting, that means it will be 0. So that means this terminal has got 1, 0. So this terminal should be 1, but unfortunately, see, this is 0. So we don't think that the bulb will be activated. Let's try the second scenario or the second option. A is 0, okay, B is 0, C is 0, and D is 1, okay. So A is 0, that means you will get 1 here. 0 0 0 multiplied by 0, it would be 0, but this is inverting, that means you will get 1 here. So 1 plus 1 would be again 1, but this is inverting, you will get 0. So this terminal got 0. So that means this terminal should be 1, right? So 1 again, that is 1 plus 1 would be 1, but that is inverting because this is NOR gate, you will get 0, right? So even this option will not work, okay? Let's try the third option. The third option is A equals to 1, B equals to 1, C equals to 1, and D equals to 0. D is 0, that means you will get 1 here. 1 is 0, that means it's 0. 1 and 1, 1 multiplied by 1, that would be 1, but this is inverting, it's 0, right? So 0 plus 0 would be 0, but it is inverting, that means you will get 1. See, you got 1 here and you got 1 on the other terminal as well. This should not work. So obviously, to me, I mean, I shouldn't try, but the option should be in this particular scenario, it should be this one. But let's try exactly if it works or not. A is 1, right? B is 0, C is 0, right? And D is 0. So if D is 0, so obviously you will get 1 here. So now this terminal should be 0. Let's try this. So 1 plus 1 would be 1, but that is inverting, so it would be 0. 0 multiplied by 0, that would be 0, but that's inverting, it would be 1. 1 plus 1, that would be 1, but that's inverting, so you will get 0, right? So in that scenario, this is the right answer, okay? So that's how you can do it. I mean, if you know the proper gates, like this is NOR gate, this is NAND gate, you can easily do it, right? So yeah, so this would be the option. Then we have question 2. This is negative OR gate, okay? So for the given arrangement, find Q. So what should be the output? So it is A complement plus B because this is OR. A complement plus B complement. That would be the answer. The third question, which of the following gates are called universal gates? There are two gates which are called universal gates. One is NOR gate and NAND gate. The same gates which I used in the first question. They are called NAND gate. The following truth table belongs to which of the following gates? So we need to see which combination gives you what. So 1 in 1, if both inputs are high, it gets 0. Both, if one is uh, at least what we say, uh, 0 and 1, it gives you 0. 1 and 0, it gives you 0. So this gate gives you 0, I mean 1 only when both the inputs are low. So NOR gate is the only gate which can give you the output high if only all the inputs are 0, right? So yeah, we can use that. In the Boolean algebra, see, A multiplied by A bar, it will always give you 0, right? Because if A is 1, the A complement would be 0. So 0 multiplied by any number would be 0. So 1, I mean 0 plus A, that will give you A. And in the same way, this is find the output voltage of the given network if input voltage is 6 volt and the Zener breakdown voltage of the Zener diode is 10 volt. See, so the Zener diode will have to get 10 volts in order to start conducting the current. So this input, the voltage is 6 volts. So obviously this Zener diode has not started conducting the current, right? In that scenario, the entire voltage of 6 volt would be dropped across Zener diode, and the resistor will not get any voltage till obviously the battery gets higher than the 10 volt, right? So this resistor will not get any voltage. So if you connect a voltmeter across this resistor, you will get 0 volts. So that's what the answer is. Okay, I hope you got the idea.